Hello, ladies and gentlemen. Welcome to JB Jumbo Online Mathematics. Today we are going to look at partial fraction. Remember, I have taught you partial fraction. Over time, we have been on partial fraction, and we have resolved about 2 examples on partial fraction. But today, we want to still look at other examples on partial fraction. From the board, you can see what we have there. It says resolve 8x squared plus 3x plus 6 all over open bracket 3x plus 1 close bracket power 3. They say we should resolve it into partial fraction. Now, how can we do this? The question on the board, how can we do it? How can we really do this? From what we have on the board, this one is a partial fraction. Why is it a partial fraction? We look at the degree of x in the numerator. The highest degree of x in the numerator is lower than the highest degree of s at the denominator. Therefore, we can conclude that this is a partial fraction. This one we have on the board is a partial fraction. How can we solve a problem like this? How can we solve it? Remember, I've taught you how to solve partial fraction. We simply split it into other smaller fractions. Meaning we are going to split this very one into other smaller fractions. How can we do that? How can we do that? It's very, very simple, quite simple. Now to solve this very one, let us start our solution like 18 x squared plus 3s plus 6 and divide 3s plus 1 power 3. Now can we really solve this very one? How can we solve this? Very, very simple. Now to solve this very one, we are going to use, remember I have given you the rules of partial fraction. I have given you, if you have forgotten, I will just advise you to go back to other class I've done on partial fraction. I've taught you the rules. Now the method or the rules I'm going to apply here, I'm using repeated linear factors to solve this very one. I'm using repeated linear factor to solve this. It means that to split this very one, it is very, very simple. To split this very one, it becomes I'm going to be having what a all over 3s plus 1 plus b all over 3s plus 1 squared plus c all over plus c all over 3s plus 1 power 2. Power 2 means this is the way or the form we can split this very fraction. It means that we have to split it until we have the highest power. Okay, this one is supposed to be 3. There is supposed to be 3 because until we have to split until we reach or we get to the highest power. The highest power is 3. Now we start from 1. We'll start from 1, 2 to 3. That is the way we split it. Now to solve this very well, what can we do? To split this one, we simply take the LCM of the denominator. I can now say, from what we have there, I can say 18s squared plus 3s plus 6 all over 3s plus 1 power 3. And collecting the LCM is simply this. Because we collect the LCM of everything, we have this one, which is going to be 3s plus 1. 3s plus 1 power 3. This one is simply the LCM. Now what can we do now? We simply use this one to divide here. I will use this one to divide here. We will use 3s plus 1 power 3 to divide 3s plus 1. It means that this one appears 3 times. It means that if it appears 3 times, it means one of these will go. If this one of these will go to the left for 3s plus 1 squared. That is what will be left when we divide this very one here. Now it means that whatsoever left, use it to times a, which is the numerator. When I times it, I'm going to be having what? I'm going to be having a, open bracket, 3s plus 1 squared. Now the other one there, we also use this very one to divide here. We also use it to divide. When I use this one to divide, it means that if this one divides now, this one divides. I told you before that this one appeared 3 times. If this one divides, remove 3 of this, sorry, two of these, we are going to be left with just this. It means that this very one times b, we are going to be having what b, open bracket, we are going to be having b, let me get it duster, we are going to be having b, here we are going to be having b, open your brackets, and we have a 3s plus 1. Plus 1, that's what we have there. Now, this one again divide here, because when this one divide, then everything will go. Therefore, I will be having what? Plus c. That is what we are going to be having there. Now, solving this very one, now we cannot start now. Solving this very one, you can see that the denominator are the same. I told you before that whenever you have a common denominator, what do? Just do away with the denominator. Now, we have to now, if I do away with the denominator, I will now be having the numerator left. Now it means that what I have left is going to be 18s squared plus 3s plus 6 equal a, open bracket, 3s plus 1 squared plus b, 3s plus 1 plus c. This is what I now have left. This is what I have left. Now in this case, now what can we do? We have to expand very well. When I expand this one, you know what it will give me? 3x plus 1 and 3x plus 1. Now what can we do here? 3 times 3 is 9. S times s is s squared. 3 times 3s plus this is going to be what? 3s. 3s plus this is going to be what? 3s. 3s. 1 plus 1 is 1. Sorry, a plus times plus is plus. 1 times 1 is 1. Therefore, what I have then, I have the 9s squared plus 6s squared plus 1. It means that if I expand this very one, I'm going to be having, what I will be having there, okay, let me repeat this side, 18s squared plus 3s plus 6 equal, I will be having a, open bracket, this is what I have now, 9s squared plus 6s plus 1. Now, I can't expand this one. This one, there is nothing. It only appears once. It only appears once, meaning I cannot expand it. I will just simply just go straight and say plus b, open bracket, 3s plus 1. 3s plus 1. That's what I have there, 3s plus 1 plus c. Meaning, that is what we have there. Meaning, to solve this very one, what can we do? We simply expand, then we simply open the bracket. We simply open the bracket for this very side, that the right hand side, I will deal with the right hand side, and I'll open the bracket. While the left hand side still remains. It means that 18s squared plus 3s plus 6 equal, now opening bracket, I'm going to be having a, going to be 9as squared plus 6as plus a. This one will also be what? B. That is going to be what? 3. Here will be what? 3bs. This one will open because of b. Open 1 times 1 is going to be what? B plus c. And at the end, this is what I have just gotten. This is what I have just gotten. I have obtained this. It means that I can bring this one has 9s squared. It means that this one has the highest power. This one has the highest power. It means that I can bring like terms together. But there's nothing to bring that we have the same like terms with this. But this and this have the same like terms. I can bring this one because this one will not be standing alone. Since there is nothing to bring together to make it the same. It means that I will just take this one, 9s squared, will be standing alone. Okay, this one and this can come. That is 6as plus 6as plus bs. Now, which other one do not have s? A does not have s, B does not have s, C does not have s. I can bring them together become what? A plus B plus C. This is what I now have. Remember, we are still dealing with the other side, with the left hand side. I'm not done with the left hand side, meaning I have to repeat it. It means that in this very one now, I can collect the one that is common on the right hand side. On the right hand side, I will collect the one that is common. I will collect the one that is common there. Which one is common here? There is nothing. This one just coming alone. I will repeat that one, 9as squared. But here, there is something common. Become what? 6a plus b. I think I'm correct. Okay. This one is going to be 3b. This here is going to be 3b plus 3b. 3bs. That is not, yes. Look at it here, 3bs. Now, which one is, okay, I can as well say here, inside the bracket can be what? Can be 6a plus 3b. Now, my s will come outside. My s will come outside. Now, what I have, other one I have is what? A plus b plus a plus b plus c. A plus b plus c. This is what I now have now. Now, for what I have there, I cannot compare. From what I have there, I can compare the coefficient on this side and also the coefficient on this side. Now look at this one. This one is 18s squared. What is the coefficient of s squared here is 18. What is the coefficient of s squared here is 9a. I cannot see that 9a is equal to 18. I'll call this one equation 1. I'll call this one equation 1. While the other one here, what is the coefficient of x here is the bracket, which is 6a plus 3b. Okay, now what is the coefficient of s here is 3. I can say equal 3. This one becomes equation 2. Now from here now, I still have another one. This one has no s. It has no s, a plus b plus c. And which one has no s here is 6. Therefore it's equal 6. This one becomes equation 3. Can you see now I have just obtained the 3 equation. From what I have here, I have just obtained 3 equations for this. Do you know that from equation 1, I can find my value for a? I can find the value of a from equation 1. From equation 1, I can find my a from equation 1. It means that a is going to be from equation 1. Equation 1 is equation 1, 9a. Let me just repeat. 9a equals 18. That's from equation 1. That's what we have there. I can say divide both sides by 9. Therefore, my a will be 18 divided 9. Therefore, I will be having I'm going to be having 2 as my value. That is going to be the value of a. Now I have just obtained a. It means that I can still as well find other values. Since I've been able to find a now, I can find other values. To find other values, I will have to put this a into equation 2 so that I can obtain b. Because here now there are 2 things here. I can easily obtain b here. Because I should put in equation 3 because this equation 3 contains how many variables here? A, B, C. It means that if I should put A here, I will be left with B, C because I cannot find 2 unknown at the same time. But the only simplest way to just do this is for me to put it in equation 2 so that it will be convenient for me to find B. When I'm done with B, I cannot find C. Okay, now solving this very one, I hope I can clean it now. Let me just go through and I think I can use this other part of the board. Let me just clean here and use the other part of the board to finish what we have there. Now, from what I've just gotten now, I can say put A equal to into equation 2. And what is equation 2? Before equation 2 is 6a plus 3b equal 3. Now, where I have my a, I will put 2 there. I will be having 3b equal 3. Now, from here now, what can we do? I can easily find b because 6 times 2 is 12 plus 3b equal 3. Now, take this one over because 3b equal 3 minus 12. And when I do that, it's going to be 3b equals minus 9. Now, divide both sides by 3. When I divide both sides by 3, I'm going to be having b equal 9 over 3. And we divide 9 by 3, we are going to be having, I think we are going to be having minus 3. Minus 3 will be the value for, minus 3 is going to be the value for b. Now we cannot find, I think we can look for every other one. The other one there is c. It means that I cannot say now, I can find my c now. It's not easy for me to find my c. Now to find c, I can say put a equal to and b equal minus 3 into equation 3. And what is equation 3? Equation 3 is what? A plus b plus c equal 6. And when I put it there, what is a? A is 2. What is b? B is minus 3. And what is c? We don't know it. Therefore, it's going to be equal 6. Now, when I do here, now here is going to be what? 2 minus 3 plus c equal 6. Now, when I do that, 2 minus 3 is going to be minus 1 plus c equals 6. Now, from here, I can obtain now the value for c. I will carry 1 over become plus, which is 6 plus 1, and the end I'm going to be having was 7. Therefore, I've just gotten the values for A, B, and C. I've just gotten the value for A, B, and C. Now, I can now represent, please, I will just give you like 1 minute to go through, 1 minute to go through, so that I can now represent or put the values into my fraction. Remember, I've splitted the fraction from the beginning. I splitted it into A, B, and C. Now I need to now put those values I've gotten now into the original fraction. Now to do that, now hope you have done that, I can claim some part of it so that I can now put my value now, the value of A and the value of B and the value of C. Now can I do that now? Yes, I can do that. Let me just quickly, I think I can represent it here. Let me represent it here. Representing it here means that I can remove this one, let me remove this one, so I can represent. This is very what I can now say now, therefore, remember what the fraction gave, I think the fraction was 18s power 2 plus 3s plus 6 all over 3s plus 1, and we have it 3 there. Remember the first one was what? A all over 3s. Okay, let me just represent A now. A was what? I think we are having A as 2. We are having A as 2 plus 1. Remember when I splinted, go back to the beginning. This is where I splinted A, B, and C. Now the B there, what is the value of B there? I think we are having the value of B there to be minus 3. I think that the value of B is minus 3. It means that where I have B, I will put minus 3 all over 3s plus 1. And remember, this other one was square. Now, what is the other one there? We have C. And what is our C now? C is, I think we are having 7. C is 7. 7 all over 3s plus 1. And we are having 3 as our power there. It means that since here is minus, this minus can affect this plus. Here now automatically become minus. It means that this one is going to be the fraction we now obtain. It means that this is the answer to this very fraction. This is the answer to this very fraction here. This is the answer to it. This is the answer to this. Now this has to split the fraction. This has to split into partial fraction. That one is just the first, I think this one is just the first example. I will move on to the second example now. I will give you 1 second. I will give you 1 second to copy, and after which I will move to the next question to solve. Thank you. Okay, I think we can now solve the second question now. We can now solve the second question we have here. Now, to solve this very one, you can see that this one is quite different from the other one I gave you. This one is quite different from the one I gave you, the one I solved, the first example I solved. This one is very, very quite different. I think the first question was, I think the numerator was lower than the highest degree of x in the numerator was lower than the one of x in the highest degree in x in the denominator. Now, looking at this one now, you can see that the numerator, the highest degree here is 3, and it's quite higher than this one. Therefore, I cannot just go direct and split it to partial fraction. Meaning I need to use a long division method first to resolve this very work, and after which I will now split it to partial fraction. Meaning there are 2 steps that are required to solve a problem like this. Now the first step is this, meaning I will have to resolve this very one. I will have to resolve it into, I will have to put it first to partial fraction first. Partial fraction first. From partial fraction we will now split. Now bring this one now, let us see. We are going to use long division method to solve. We are having the first one, what is it there? 3s power 3 minus s squared minus 13s minus, I think we are having minus 13. All over, we are having s squared minus s minus 6. Can see this one is higher. Therefore, I will have to want to use long division first, long division method first to solve it. Now to use long division method to solve, what can we do there? Let me just put it aside, let me put it aside so that it will be more convenient for us. I will use long division method. To use long division method, I will say this one, numerator will go inside. The numerator will go inside. What is the numerator? We have 3s power 3 minus s squared minus 13s minus 13. That's what we have there. That is the numerator. It will go inside. While the denominator will come outside, we have s squared minus s minus 6. This is what we have outside. This is what we have outside. It means that solving this very one, what can we do? Solving this very one, what can we do? We use the highest power of x here to divide the highest power of x here. That's what we do. When we are solving a problem like this, we use the highest power of x here to divide here. As you see, 3s power 3 divide s squared. Therefore, this will go cancel two of these. I think we're going to be having 3s. Now 3s, now bring it to this point. Use the 3s to times everything you have here. Everything you have here. Meaning it's going to go 3s times s squared, it's going to go 3s power 3. 3s times s is going to go 3s squared. We're going to be having 3s squared. 3s times this, we're going to be having 18. You mean at that point, then we're going to be having what? 18. Here is going to be what? 18s. Therefore, now what can we do there? Remember, I told you that there is invisible minus at this position here, but minus is not always indicated. We don't always indicate the minus sign. We simply, I think we simply will hide the minus sign. Now, to do this very one, what can we do is subtract. When I subtract, I'm going to be having nothing here when I subtract. Now, I think I can also subtract some minus. Remember, I told you there is invisible minus is plus because minus s squared plus 3s squared, and then I think we are going to be having here, we are going to be having 2s. When I express that, I think we are going to be having 2s squared here. That's the answer there. 2s squared will be our answer there. Now also say minus will also be plus. Minus 13s plus 18, we are going to be having 5x. Now in this case, now you anything to express here, nothing. Just say minus 13, drop it, minus 13. Now in this case, now I can still go further and say the highest degree, what's the highest degree? Until I will have to reduce this one till this one is now lower than this. Like the highest degree here is now lower than this. Now they are still of the same degree because the highest degree is 2. The highest degree is 2. It means I need to reduce this one again now, divide this one by this. That will say 2s squared. 2s squared divided by s squared. Therefore, I'm going to be having 2 there. Therefore, here now is going to be plus 2. That point there will be plus 2. 2 times everything here. 2 times everything here. We're going to be having 2s squared. Here is going to be 2s squared. 2s squared. 2 times this. We'll be having minus 2s. 2 times this is going to be what? Minus 12. Now, remember I told you at this position, there is always what? Invisible minus. There is always what? Invisible minus. Now, what can we do there? We can minus the area, will be left with nothing. Now, minus here, minus is plus. When I do here, we are going to be having 7s. Now, minus is plus 13s plus 12s. We'll be having minus 1. Check it out. We are going to be having minus 1. Check it out. Let me remove here now. Let me remove it. Do you see that the degree of here now, the degree of s here now is now lower than this? Therefore, I can stop here. I cannot see, in this case now, I cannot see what particle we're having a fraction, this is the fraction we're having. I can say 3s power 3 minus s squared minus 13s minus 13 all over s squared minus s minus 6 is equal, what do we have? Okay, please let me remove this one first. Let me resolve here first. Remember I told you here is quotient, here is remainder, while here is divisor. Please don't forget here is divisor. Meaning I can say now I'm using this very one, Q plus R over D. I'm going to be having, I'm using this one. Now what is the quotient there? The quotient is 3s plus 2 plus, now what is the remainder? The remainder is 7s minus 1 all over what is the divisor? We have s squared minus s minus 6. Now, therefore, now this is what I've just done. It means I'll be able to resolve this very fraction, this very one here, into this very one. Therefore, now, here now, I have the partial fraction now. I have a partial fraction. And what is the partial fraction? You know, I told you whenever the highest degree in the numerator is lower than the one of the highest degree in the denominator. Therefore, we can conclude that this fraction is a partial fraction. Now, resolving this partial fraction, there is 7s minus 1 all over s squared minus s minus 6. So we are going to be having, remember with springs. Okay, now factorize here. If I factorize here, we are going to be having, okay, let me say 7s minus 1. If I factorize here, we are going to be having an s plus 2 and also what? S minus 3. Let us see now. S plus 2 and s minus 3. Let us see. S times s is s squared times this minus 3s. This one times this plus 2s. Plus minus is minus. 2 times this is 6. Is 6. Therefore, if I express here, now it's going to be s squared minus what? S. Because minus 3s plus 2s is minus s minus 6. Therefore, you can see now, I'm going to expand these two things here and I obtain this very one. Therefore, we are correct. We are very much more correct. Now, to solve this very one, what can we do? To solve this very one, we simply move on to split now. We simply move on to split. Remember, I told you we always split partial fraction. We always split partial fraction into other smaller fraction, like using A or using B or using C. Now, to split this one becomes A all over S plus 2, yeah, plus 2. 2 here, this let me put it here. That is A all over S plus 2. And we also have what? Plus B all over S minus 3. You can see there. This is what we have here. This is what we have here. Now, therefore, I've just split now. I can now resolve it, and since I've split I can now resolve. Collecting any LCM here, I need to get my LCM here. If I get my LCM here, I'm going to have what? 7s minus 1, s plus 2, and also what? S minus 3. Now, taking the LCM is going to be what? S plus 2, and also what? S minus 3. Now, when I do this, and okay, now this one into here, since I've collected my LCM, I need to now use this one to divide here. Whatsoever I have, I think I will be left with this when I divide this now. When I divide this one, I will be left with this one. Times it by this one, multiplying this one become what? A open bracket S minus 3. This one will also divide here, left with this, times this one, become what? B, which is S plus 2. This is what I now have now. This is what I have. Can you see that you can see now that from what we have here, the denominator are the same. I told you earlier that whenever you have a common denominator, what do? What can we do there? We do away with the denominator. We can do away with the denominator. If they are common, we can do away with the denominator. You mean that when I do away with the denominator, what I will be having is going to be 7s minus 1 equal A, which is A, open bracket S minus 3, and also what B, which is S plus 2. Remember in the first one, I used different steps to solve it. I also use different steps to solve this very one. But remember that even these two steps I'm going to use in this one, the two steps I want to use in solving that the one I used before and the one I'm using now, which is now two steps. I've used it before to solve. Go back to other of my class. I think I've done something like that. I've used two steps to solve a question. But here now, time will not permit me to do two steps to solve this question. I will only use one step. I will not use that same step I used in the first example. I will use another step to solve this one. Now, using this one, I'm going to use substitution method to solve this very one. Using substitution method, let us see what we can do. I think I can clear here now. I can clear this position. Now, solving this one, what will I do? I will have to say, I have to eliminate one. I will have to eliminate one and keep one. I will have to eliminate one and keep one. Now, which one will I eliminate? Let me eliminate B and keep A. Eliminating B, what is there? What is inside B? Inside B, we have S plus 2 equals 0. If x plus 2 equals 0, then x now become what? If 2 move over, become minus 2. It means that wherever I have x, I will put minus 2 there. It means that in this case now I can say 7, put bracket minus 2, minus 1, equal, now the other one will also be a, bracket, open bracket, minus 2, minus 3. Now the other one will be b, which is minus 2, minus that plus 2. This is what I will be having this other one. This is what I'm going to be having the other one. It means that this one can go I think that one can go. That one can go. That one can go, of course. Can go. That one can go. This one is divisor, please don't forget. This one is divisor. Now, if that one go down, I'll be having this one again. That is 7 minus 2. Minus 2 is minus, I think it's going to be minus 14. Minus 14, minus 1. I'll be having minus 15 here. Minus 15. I'll be having minus 15. I'll be having minus 15 here. I'll be having minus 15 here. Now, for what I have there, okay, let us see now. For what I have there, let me see. Let me see here. Okay, I think I'll be having the other one. The other one will be what? Here will be what? Minus 5. Minus 5, 8. Yes, this is what I'm going to be having there. Minus 5, 8. Now, what will I do? I will have to divide both sides. I will have to divide both sides by minus 5. Minus 5, which is going to be dividing minus with 3 minus. Therefore, I'm going to be having what? I think great. Let me see. Minus 15 divide minus 5. Minus will keep minus. Therefore, I'll be having 3 as my answer because 5 into 15, I will be having 3. Now, I've gotten my A to be 3. Now, I need to now obtain my B. To obtain B, I need to do away with A and keep B. It means that to do away with A and keep B, I will have to consider what's inside A. What is inside A is x minus 3 equals 0. Therefore, if x minus 3 equals 0, what will be the value of x here? Meaning 3 will move over because x equals 3. I'll be having what? S equal 3. Now, in this case now, I cannot say, wherever I have, I also use the same expression here. This is what I have here, this same equation I have here. I will also put this s into it, s equal 3 into it. It means that it's going to be 7, open bracket 3, minus 1, equal, I will be having the other one there. The other one will be A, yes, which is 3 minus 3, and the other one will be B, which is what? Minus, okay, it will be 3 plus 2. That is what I will be having there. It means that this one can go when I minus, this one will now be what? 21 minus 1, here will be 20. Now, doing this one, I become, okay, here will be what? I think here it's going to give us 20 equal, here will be 5. Yes, 5b. Now I can divide both sides now by 5. When I divide both sides by 5, we have what? B as 4. I'll be having B as 4. Now therefore, I'll be able to obtain the value of B, and I'll be able to obtain the value of what? The value of B and A. Therefore, I cannot represent my fraction. I cannot represent my fraction. I cannot see. And what is it there? Originally, we have what? 3x squared 3. Minus s squared minus s squared minus 13s minus 13 all over, I think we are having s squared minus s minus 6. What will resolve it into, using log division, what will resolve it, we're having I think we are having 3s plus 2, or today 3s plus 2 plus 7s minus 1 all over s squared minus s minus 6. This is what we were having there. This is what we're having there. When we obtain that, this is what we're having. We just go through it. This is what we're having. Now, I cannot conclude now and present. Remember when I did this one, I did this very one. This is what I have. I think I splitted it. I splitted it into two other fraction. I will have A over this and B over this. Now, to do this one now, what can I do now? I have to represent the value of A and B in the fraction. I cannot see now. I hope we are through this one. I hope we are through this one. Just go through this so that I can clean part of it there and conclude my solution. So that I can conclude the class. So let me remove here so that I can conclude. Let me remove here so that I can conclude. Removing here now means that this one I can continue with this one and say, I can continue with this one and say, this very one here I can say 3s plus 2 plus, and what is our value for this one? We are having this one. This one was this very one. What is our a? A is, I think we have a as 3. A is 3 all over, I think we are having s plus 2. And we also have b. What is our b? B was 4. B all over s minus 3. This is what we have there. I think this is what we have. Therefore, we are able to resolve this fraction now. Mean we are able to resolve this fraction. Let me remove here. And we have done with this place here. Let me remove here. It means that here now, remember here was 3. Here that point there was 3. That point there was 3. Let me write it well. Here was 3. And here was 4. Therefore, I'll be able to resolve this fraction now. This is what I have when I resolve. This is what I have when I resolve. I was having this very one. This is what I have when I resolve. Therefore, I can conclude here now. I can conclude now. I can conclude. This is what I have when I resolve. This one now become my answer. This one become my answer, my final answer there. Therefore, I hope we are okay with this one. We are okay with this one. We are able to solve now. Meaning that here I can conclude my class. I can conclude my class. Let me see if you can still solve other example. Can still solve one more example. And at the end, we conclude partial fraction and move on to polynomial. Thank you. God bless you for staying with me in this class.